Hello, my name is Marcelo Albuquerque, and together with Marco Micheli, my mentor and stakeholder on this project, I have been working on the Translation Quality Assurance by School Challenge. This project has been sponsored by Translated. Translated is an Italian company that offers human translation services in over 190 languages. It matches customers with thousands of translators worldwide. Each translation job goes through a sequence of a machine translation step using the modern NMT engine and a human translation step. The quality of a given translation job is assessed by human reviewers, which categorize and count each identified translation errors. Due to an inherent subjectivity of the translation error reviewing process, it's very common that different reviewers identify a different number of errors on each translation job. This makes comparisons of translation scores difficult and leads to noisy error score estimates. Not all reviewers are equal, and some show systematic biases, identifying more errors than others. To mitigate this problem, translation companies commonly employ simple average corrections and multiple review workflows, but these incur an additional costs and do not provide reliable uncertainty estimates of translation error scores. To cope with the different sources of noise in the translation score estimates, we identified latent factors that contribute to the number of reviewer-detected errors on each translation job, namely the latent factors: job difficulty, translator skill, and reviewer strictness/leniency, all of which contribute to the number of identified translation errors. Our solution consisted of a Bayesian beta binomial generalized linear regression model implemented using the PyMC3 library. The beta binomial is a standard choice of distribution to model over-dispersed counting processes. We use hierarchical structures for covariates representing job difficulty, translation skill, and reviewer strictness, making it easy to perform bias correction for reviewer systematic errors. Using a Bayesian methodology, our model assesses the full posterior distribution and thus the uncertainty associated with each error score estimate, which is a novel application of Bayesian uncertainty estimation in the translation industry. Posterior distributions of biases for the strictness of each reviewer and for the skill of each translator were evaluated on an experimental dataset provided by Translator. The biases indicate that indeed some reviewers may increase, while other reviewers may decrease the odds of translation errors being identified, which we interpret as an indicative of reviewer strictness or leniency. Identifying the systematic biases, our model enables the correction of undesirable systematic errors and the evaluation of more reliable translation error metrics. For each translation job, the model provides an assessment of the reviewer bias corrected estimates of error scores. In this plot, we can see in black observed error scores for a sample of translation jobs in our dataset. The colored dots and intervals show the posterior bias corrected credible intervals of error scores. Strict reviewers, such as reviewer L, tend to have its error estimates lowered. Lenient reviewers, such as reviewer A, tend to have its error estimates increased. In this way, our model provides uncertainty assessment and bias correction of translation error scores using a Bayesian workflow, improving on the current adopted methodology that utilizes simple statistical averages. One opportunity for future work is to model different error categories, such as style, accuracy, or linguistic errors. A Dirichlet multinomial model, which is a multi-category extension of the beta binomial model implemented in this work, would enable the evaluation of the tendency of reviewers to identify different categories of errors, for example. Our team consisted of me, Marcelo Albuquerque, an electronics engineer with a master's degree in computer science, and Marco Micheli, who served as mentor and stakeholder for the Spy School Challenge. Marco works as a research scientist at Translated and is currently a PhD student at Universidade degli Studi di Roma La Sapienza. Thank you for your attention.